In this video, we're going to look at deferred annuity problem. The template is already available to you. So the problem here is it's the extension of annuity. We have seen annuity problems here previously in the previous lecture, and in this we are going to extend these annuities into something called deferred annuity. So the problem is Jasmine is 35 years old today. She plans to retire 30 years from today, and she will require $125,000 per year during her retirement. So when she retires at the age of 65, and from that point onwards, she needs $125,000 per year during her retirement. So Jasmine is retiring at the age of 65. Then she is expected to live until age 100. So she is going to live from 65 to 100 years in her retirement. The retirement account is going to get 8% per year before retirement. So before she retires, she is going to invest in maybe high risky assets such as stocks, and she is going to get 8% per year. Then after she retires, she is going to reduce risk in her portfolio. As a result, she is going to get a lesser return after she retires. So given this information, how much Jasmine has to contribute to her retirement? So between now and until she retires, how much she has to contribute every year so she can have $145,000 a year after she retires. That is the problem. And now let's look at the template. Okay, this is the deferred annuity problem. All these things are already filled for you. Annual retirement income need is $125,000 from 65 to 100 years. Years until retirement is 30, from 35 years to 65 years. Years in retirement is 35, from 65 years to 100 years. Rate of return before retirement is 8%. This is from years 35 to 65 years. Rate of return during retirement is from 65 years to 100 years. So these are just labels, and they don't have any, they are not the inputs for any calculations. This is just for your information only. Okay, now let's come to savings required at retirement. How much money she needs when she retires. Okay, so this is going to be when she retires, that's the present value. The rate of return is going to be 6% from 65 to 100. NPER is 35. Payment during the retirement, she is expected to withdraw $125,000. So she is going to withdraw minus, because she is withdrawing, $125,000. Future value is 0. That is, when she is 100 years old, she doesn't need any money. The type is 0 for end of period. Okay, so with this, you can see that she needs $1.8 million when she retires. So this is at 65 years. As soon as she retires, she needs to have $1.8 million in her account, so she can keep getting $125,000 per year from that point, from 65 onwards. Okay, so now the question is, how much she has to, what is the value of this today? We know she needs $1.8 million at 65, but what is the value of this at 35 years, which is today? So we're going to calculate the present value of this amount. So between 35 and 65, the rate of return is 8%. N per is 30. Payment, she's not contributing any additional amount, so it is 0. Future value is this, and 0 for end of period. Okay, so we want to put a negative number here, so this number is positive. Okay, so all in all, what it means is the $1.8 million at 65 years is equivalent to $180,000 today. Okay, now the question is how much she has to contribute when she is working from 35 to 65 towards her retirement. Okay, so this is the present value of the annuity and what is the payment required. So the payment required is going to be 8% return. N per is 30. Present value is 0 because she doesn't have any savings today, and the future value is going to be $1.812 million. We have to have a negative 0 for end of time period. Okay, so basically she needs to save, this is the answer, $15,997.79 every year, so she can have $125,000 when she retires. This problem is a little bit difficult for some students to understand because she's saving only $15,000 a year, but she will be getting $125,000 later on per year. So she's going to get a lot more, it looks, than what she's contributing today. But the main difference is the $15,000 is, this is in today's dollars, and this $125,000 is in future dollars. Okay, now let's move on to the next worksheet.